In this video, we discuss the existence of the terms of the sequence, of the recursive sequence. So let's define first the sequence that we have is defined by u sub 0 equals 5 and u sub n plus 1 equals the square root of u sub n minus 1. So we can see here that our function that defines the sequence is the square root of x minus 1, and he's mentioning that x belongs to the domain df, and he wants to find this domain, and then we will discuss the existence of all the terms of the sequence. So let's start with the first part, which is the domain of the function, and then he wants to prove that the df, to check if the df is mapped to itself by f, and third, he wants to find the values of u1, u2, u3, and u4. So let's start with the first part, which is the function f and the domain of the function f. So we have f of x equals the square root of x minus 1. And here, of course, this is correct if and only if x minus 1 is superior or equal to 0. Of course, it's the square root of x minus 1. So this means that x belongs to 1 plus infinity. Okay, so the domain of the function is 1 plus infinity. We go now to the second question, which is about proving that or checking if df is mapped to itself or not. So here we need to see the variation table and see how varies f in the interval 1 plus infinity, so we can find the image of 1 plus infinity using f. Okay, so we start with the derivative f prime of x equals 1 over 2 square root of x minus 1, and of course here the derivative has to be different than 1, and we know that the f prime of x is strictly positive whatever was x strictly superior than 1. So we draw the variation table of the function. We have here 1 and we have here plus infinity. So for the derivative, it's not defined on 1 and it's a positive function. So we pass to the function f, which is an increasing function that is going from 0 to plus infinity. So we can see here that the image of 1 plus infinity using f, when we use f, is 0 plus infinity, and this interval doesn't it's not included in the 1 plus infinity. Okay, so this means that the df is not mapped to itself. Okay, let's now see what are the consequences of this result. So concerning this result, we can say that if we want to find the u1, we have, of course, the u0 equals 5, and the u1 is going to be 5 minus 1, so it's equal to the square root of 4, which is equal to 2. Then we have u2 is the square root of 2 minus 1, so equals 1. We have u3 equals the square root of 1 minus 1 equals 0, and then you have u4, it's equal to 0 minus 1 equals the square root of minus 1, which is impossible. So we can say here that because we are having u0, it belongs, so the result is going to be because of u0 that belongs to a domain that is not mapped to itself. This means that the elements of the sequence will not exist after a certain range. So here we have U0 exists, U1 exists, U2 exists, but then after that, we can say that U4, whatever was n superior or equal to 4 UN doesn't exist, does not exist. Okay, so this is the first example with this type of problems that proving that the sequence cannot be existing anymore after a certain number. So let's move now to the second exercise or the second example to see a second problem that can also conclude to the non-existence of the sequence.